right, we're gonna review a couple old concepts, and we're gonna merge some new concepts with the old concepts, and we're gonna come up with new rules. And I'm confident you guys will do very well on this. Look at the first problem, x squared over x cubed. This is review. How would you simplify this? How would you simplify this? Can you simplify it? Can you? Yes or no?
Yeah, it's x over x squared.
X over x squared.
Or no, wait, I don't think you can.
Let's look at the visual picture. What's another name for x squared?
X. Times X.
What's another name for x cubed?
X times
Right? So what can we cancel?
Two X's.
And what's left?
X.
X where? You mean
So
1
over
over
X.
x? You mean 1 over x?
Yep.
Yeah.
Okay, good. 1 over x. Now, do you remember the rule when you're dividing? What do you do with the exponents? Remember the rule? How do you think you get the exponent of 1 here? You subtract. Now, is it true that if you subtract 2 minus 3, you get what, -1? Is it 2 minus 3, -1? So how did I get this x down here? What's the rule? If you have a negative exponent, what do? Bring it down. It's in the top, it's -1 on top, so you're gonna bring it down and make it x to the +1. So there's a couple rules we're utilizing today. We're reviewing when you're dividing the rule, if the bases are the same, you subtract the exponents. You may need to know something about the negative exponent, what to do with it. And the last thing I want to talk about is a problem like this. What can we do with this problem? We learned this in section, I think 6.2 and 6.3. Can I simplify this problem at all? How do you know if you can simplify it? If the indexes are the same, how would I simplify this? What would I do?
You divide.
Yeah, you divide. 2 goes into 16 how many times? 8. So cancel that, you get a 1, you get an 8 here. How about the x's?
X to the third.
Where?
So on the bottom.
X to the third. Now, what you can do is simplify. The cube root of 1 is 1, the cube root of 8 is 2, and the cube root of x cubed is x.
Do you have to put it over 1? Because I know.
Yes.
Oh, okay.
Now, if it were reversed, if this were on top, do you need a 1 on in the denominator? No, but you do in the numerator.
Alright.
That's a good question. All right, so now, what did you say you can reduce if the indexes are the, what if they were not the same? So now we are in problem 4. Does everyone have this? Now we're in problem 4. Can I cancel these 2 x's with 2 x's here? No. Say it louder. No, why not? The indexes are not the same. So Mr. Duke showed you a way yesterday how to convert this another way. How can you rename this the 4th root of x cubed?
X 3/4.
Say it louder.
X and 3/4.
X to the 3/4. Good job. X to the 3/4. How can you rename the 8th root of x squared? 2 over 8. Excellent. So this is what you have. Sorry I didn't give you a lot of room here, but I had a lot to copy.
Yeah.
Sounds good to me. Let's do that. I was just gonna say, and we do something to that bottom fraction. So you're seeing it, we can reduce that. So now, what was that rule that we did over here? The quotient rule, if the bases are the same, what do you do with these two exponents? You subtract them. Guess what? Bases are the same. What do you think you're gonna do with these two exponents? You're gonna subtract them. So you've got 3/4 minus 1/4. Now you should be able to do that in your head. What's 3/4 minus 1/4? Is 2/4,
1/2.
which is, oh, see, you got it, which is 1/2, which, can you rename this another way?
Square root of x.
Excellent, that's it. The rule is this, if they ask you a question written in radical form, you really should answer it in radical form. But will I accept this answer? Absolutely I will. It's like good, better, best. This is the best answer. This is good. They're both correct, but this is the best answer. Think of these are two different languages. Okay? Let's try another one.
I can't reach it.
Now, look at got it 4A. If I gave you this problem, can we do anything with this 4 and then multiply?
Take it in, break it up.
You can break this 4 up into 2 times 2. And because these indexes are the same, and we're multiplying,
You can put them all together.
can we reach over and grab those 2 and group them together? And what's my answer then?
2.
2. Did everyone catch that? So when you're multiplying and the indexes are the same, you can reach over and grab and make your sets of whatever of a kind you're looking for, right? But now look at this one. Are these indexes the same? Oops,
No.
going the wrong way.
Talking about for A?
A.
No.
Are these can I reach and grab this 3 and group them together?
No.
No. So, but I can do something to this problem. I can rename this as what? 3 to the 1/2 power. And what operation are we doing when you see a parenthesis? What, well, multiplying. And what's another name for the 4th root of 3? 3 to the what power? 1/4. So now, can you rename the product, or actually, what are you going to do with these 2 fractions? Add them. When bases are the same and you're multiplying, you keep the base the same. Do not write, this is a common mistake, people will write 9. It's not 3 times 3, it's just 3. What we're going to do is manipulate these 2 fractions. What's 1/2 plus 1/4? What's your common denominator?
4.
2/4?
2/4 plus 1/4 is
3/4.
3/4. That's it. Now, can I rewrite this in this language right here?
Yes.
What would it be?
It'd be 3 and then to the 3rd power and the index of 4.
Yep. You said it right, and I'm writing it wrong. So it's the 4th root of 3 cubed.
Sounds like Spanish.
Okay, let's see if you can do B. B is just like the one we did in the example up here. Can I cancel these out? And tell me why. No, because the indexes are not the same. So next step is to rename this. How are you gonna rename the square root of x cubed?
X to
3 over what?
1, 2, sorry.
3 halves power, good. How are you gonna rename the cube root of x squared? Yep. So what do? If bases are the same and you're dividing, you keep the base the same and do what to these two exponents?
Subtract them.
I want you to subtract them. Now, for those of you that are not good with fractions, maybe what you need to do is see us and learn how to get a common denominator. But I'm gonna show you how to do it on a calculator too. But I don't want the calculator to replace you using, exercise that brain. What's the common denominator?
6.
6. So you got 9, 6 minus 4, 6, which is what?
5, 6.
5, 6. So how do you write x to the 5, 6 power?
6 root of x to the 5th power.
Got it. That's your answer. And the last one, C. Can I grab this 7 and pair them up? No. What's stopping us? The indexes. So can you rename the square root of 7?
X 1/2.
7 to the 1/2
That's what I
power.
meant.
I know. And how about the cube root of 7?
7 to the 1/3.
What's your common denominator?
6.
Now, how do you do these fractions on the calculator?
1 divided by 2 plus 1 divided by 3.
Here's another way, that's one way. I really like this fraction button on this. How many of you guys use that? I love that button. So you can simply just do 1/2 plus 1/3. Let's try this one. 1/2, arrow over, plus 1/3, and then hit enter. Guess what you get? 5, 6. So, what's the answer here? 7 to the 5, 6 power. Can you rewrite that though?
Yeah.
How?
6 root
6.
7.
Beautiful. So now, for homework, in about 5 minutes, I'm gonna let you guys loose. These 8 problems are just like these 4. I want you to practice and get good at these. But I want you to take another look. We're gonna add one more thing, and I didn't leave you a lot of room, but I want to see if you understand this. What do you see in A? 16, can you read that to me?
Negative
2.5.
Negative 2.5. So, believe it or not, this problem, you could type it in your calculator, simply. Watch, I will do.
Can't see.
So if you did 16 raised to the negative 2.5 power, negative 2.5. You get that decimal right there, 0.000977. But that's not the answer I want. Watch how I'm going to show you. That is one way to do it. And now what you could do is convert this to a decimal. If you hit menu, number, and approximate to fraction, and then hit enter, that's the answer I want you to get. So these two are actually the same answer, but I'm going to show you how to get this without using a calculator.
Can't
By-
you just approximate it to a fraction from the get-go instead of...
Watch. How do you get rid of a negative exponent?
You flip it?
You flip it. So do you agree that this is 1 over 16 to the positive 2.5 power. Do you agree?
Yeah.
Is that true?
Yes.
Okay. Do you know how to convert 2.5 to a fraction?
Yes.
What does it look like?
What is a fraction?
What does 2.5 look like as a fraction?
5 over 2.
2.5, or, he's right, 5 over 2. So far, are you agreeing with what I just did? My sequence.
Yeah.
Now, can you convert that fractional exponent to a radical? What does it look like?
1 over 16, or the
Square.
yeah.
Square root of 16. How many of them do we have? How many 16s do we have, everyone? 5 of them. So for those of you that are visual learners, watch this. Do you agree with what I'm writing? I have this, times this, times this, times this, times this. Do you agree or not? This is the long way of doing it, but I'm showing you where 1024 is coming from. What is another name for 16? 4 and 4,
2, 2, 2.
and 4 is 2 times 2. So do you agree that we've got 1, 2, 3, 4 2's here, and then we have 4 more, and then we have 4 more, and 4 more, and 4 more. That's one way of doing it, but that's too long. Let's group it easier. How many of a kind are we looking for?
2.
2. Do you see 2 of the same number?
Yeah.
I do. Do you see 2 more of the same number? Again. Now, what is this? This is
2 times 2.
2 times 2 times 2 times 2. Do you see 2 of the same number?
Yes.
There's 1 and there's 1. Or you could have said 4 times 4. So what are you going to pull out? You're going to pull out a 16. You're going to pull out another 16. And you could have thought of this as 2 4s. Or 2 times 2. However you want to look at that. So what is 16 times 16 times 4? Does it make sense? Okay, we're gonna do A, B, and C, and I'm so sorry I did not give you a lot of room. I was trying to squish it all on one paper, so you may wanna write this on a separate sheet of paper. Now, you could easily type this in your calculator, but I want the brain to be used more than the calculator. Use the calculator to check your answer. So let's do this in order. Step 1, and by the way, if you can't read it, it's 32 to the negative 3/5 power. So step 1 is to get rid of the
Negative.
negative. What does it look like turning this positive?
1 over 2.
Agreed? I want everyone to agree, yes or no? Yes. Now, can you rewrite it in exponential or radical form? How do you rewrite this in radical form?
5th root of 32 to the 3rd power.
Yep. So do you agree that you're looking for 5 of a kind, but you have 3 32s? Break it down. Does anyone know what 32 consists of?
5.
Good, 5 2s. So you have 2 times 2 times 2 times 2 times 2. This consists of 5 2s. And what are we looking for? How many of a kind?
5.
5 of a kind.
2 times 2 times 2.
There you go, you got it. 2. So this is going to result in another 2. This is a 2, and this is a 2.
It's 1/8.
1/8. You got it. Using the brain. Now let's do it on a calculator and see. Let's check. I mean, I could easily show you guys here, use your calculator. But it's like watching someone on TV do aerobics and thinking that you're gonna sweat watching them. Your brain is not gonna be used if you use your calculator. You wanna do this. So can you guys type this in your calculator?
Yeah.
Another reason why you wanna do it in steps is because I could easily type this in my calculator and accidentally type a wrong number. And then I get the wrong answer. But if I can show some work, I can give you partial credit, right? So 32, and then power, and now I believe you have to do parentheses. -3 divided by 5, parenthesis, and then if you hit enter, bingo, you got 1/8.
Is that cheating?
It's not cheating, it's
Laziness.
It's laziness, but the thing is when you type this in your calculator, are you getting anything out of it?
Just as
You're
I
not
said.
using your brain, but see the steps, if you can follow those steps, then you're actually learning all those different concepts. You know how many concepts are involved in that? A lot. You tell me, 16 to the 3/4 power. How do you rewrite this? Let's use our brain first. 16 to the 3/4 power. Is it a negative exponent? No, so don't be switching everything. If it's not negative, don't move it. So do we move this, yes or no? No. How do you rewrite this? The 4th root of 16 3 times. So I have 3 16s, so this is what this looks like. I have 16 times 16 times 16. And do you know what 16 consists of? 6 fours?
Well, all three of them.
You mean 4
4
twos?
4 2.
I know what you meant. 4 twos, these are 4 twos. So you're gonna pull this one out, and you're gonna pull out another 2 here, because that's gonna be 4, I don't have to write it out. And I'm gonna pull out another 2, so what is this answer?
8.
8. Now type it in your calculator. Type 16 to the 3/4. Pat yourself on the back. Did you get 8?
So are you saying you want us to do it this way throughout the whole homework, or?
Yes, I want you to do it because what you're doing is learning.
So I'm not allowed to use a calculator?
You can use a calculator to check your work. I know it's but in the long run, you'll thank me. How do you do this last one? I'm gonna shut my mouth and I'm gonna let you guys direct me.
It's a negative, so you have to flip it.
To put it over one.
Caitlin, you're on. Caitlin. See? You gotta flip it. Yes?
Yeah.
Then what? This is the hardest one.
Convert it to
Are you okay, buddy?
It's gonna be 7.
9 over 7.
You think we should? You think we should?
3.
D'Angelo, you're on.
Oh, we,
You told me what to do. You
oh, I
said
said it's
convert it.
9, yeah, 9 7 over 2.
Yep,
Yeah,
And
that makes
then
sense.
It's 9, no, it's square root, or no, 7. Yeah, square root of 9, 7.
Mm-hmm.
And then I do it a different way. I always just take the 7 through to 9 and then square root it.
Okay,
But you do it, you break it up. You can break it up into
into what?
3, I think 2 3s.
There's 7 9s. We're looking for how many of a kind?
2.
So there's 1. There's 2. There's 3 9s. But can I break this up into 2 of the same number?
3 and 3.
Mm-hmm. So what's my answer? 1 over 9 times 9 times 9 times 3. 1 over what? Okay, Jack gave us 1 over 2,187. Is he correct? Yes. Now look at all these concepts you're showing me. You're showing the state of Michigan that you know what a negative exponent is by doing that.
What was the final answer?
You're showing the state of Michigan that you know that 3.5 is 3.5. That's another concept. You're showing that you can change a mixed number to an improper. You're showing that you know the different languages between rational and radical form. You're showing that you know what a radical is and how to take it out. And you're showing how to simplify this. So, did you get the right answer? Did you check it on your calculator? Can I see someone's calculator that got it? Hey, Jack did it. Here it is. He did 9 to the negative 3.5 power. He came up with that answer. And then he converted it. He hit menu and he converted it to a fraction. Now, if you're taking the ACT test, is anyone in here scheduled to take the ACT test? Okay, let me just tell you something. You guys are 1 foot out the door. Actually, get half your body out the door, right? Of the school. You're going to college, right?
Yeah.
Okay, my job is to help you. One of my jobs is to help you get ready for college. You know, I teach at Macomb. I teach at Macomb, so I have some knowledge. You can turn that off.